Yes, so I found this crate, which is a very normal object in most games. You always have to have crates for some reason. Um, oh, what's the matter? Oops. There. Oh. I don't know what happened there. So this is a good example. This is the texture. So it also shows that if you want to map a three-dimensional object, then you sometimes have to be a little creative with using the texture space. This is a normal kind of mapping. It wastes quite a lot of texture space, of course, but it's easier to see what's going on. So in 3D, it's a crate that has texture on all 6 sides. And then, apart from the texture, of course, there has to be a set of UV coordinates that match all the vertices on this to properly map onto the UV space so the texture is drawn correctly on the crate. Just So we do the same as we did on the previous slide. We look at a single triangle. Same thing happens for each triangle. So we say maybe here there's a triangle. Probably there is, because each of these quads is probably just 2 triangles. That would be the easiest way to generate the geometry. And I again put similar designations, so we know which vertex is which. This is VA, VB, and VC. And then we, again similarly, choose UV coordinates. 1 UV coordinate for each vertex. And now we have to look at the texture a bit to get a mapping correctly. So I think maybe it's this one here that we want. So I'm going to draw the triangle here in UV space. So we want, I mean, the tip of the triangle is actually there, right? Oh, oh, what's happening? Yeah, exactly. Yeah, so this is what we want. We want this part of the text to be mapped onto this triangle. And therefore we have to look at the UV coordinates. Got a bit low there, but never mind. So I'm just gonna put the UV coordinates here so we can see them. That's 0, 0 on the U. That's 1, 0 U. It's always the entire extent of the texture, 0 and 1. And on V, similarly, like this. And there. That's a bit thick. So at this point here, where these vertices are, this is like 2/3 up the axis, so that must be 0.67. And on V, of course. And this point here is a quarter along this axis, so that must be 0.25. And this point is exactly half, so that must be 0.5. So now we can look up the texture coordinates. So VA is this vertex here. So the texture coordinates of that one is 0.5 and 1. On the U axis it's 0.5, and on the V axis it's 1. And VB is this here, that's 0.25 and 1. And VC is this point here, it's 0.5 and 0.67. Yeah. Okay, so now we come to something called tiling, which is a useful thing you can do, repeating a texture, like this example of a brick wall. Texture tiling. So there's this one here, and this, as you say, this texture is tileable, which means that it has been adjusted at the edges. So if I put several of these next to each other, the seams will be invisible. I'm just going to resize it so it's maybe like this. So we can do like this. And we should get like a seamless wall. Yeah! Hooray! It's almost magic, isn't it? Yeah. The way we do that is to go beyond the 0 and the 1 on the texture coordinate, and the hardware sort of does this for us automatically. So let me just draw the geometry. Like this is actually like a geometrical quad that's drawn somewhere in space, and it has these 4 vertices. And I'm just going to put an outline of exactly one texture here, which is like something like this. Can't even see it anymore, but somewhere like there. That's like one instance of the texture. So in order to accomplish that, we use these coordinates higher than 1. I should have some smaller. This is of course just 0. And this vertex then has a UV coordinates of 3, 1. Because there's 3 instances of the texture here, so it has to be 3. And up here it's there's only 2. 1 and then 2. Here it's like 3, 2. Just wanted to draw it in another way. Over here. So when we draw a UV space, we always put the texture at with the bottom corner at the origin, like this. And the edges here are of course 1. And just to be clear, this is the texture image, it's not geometry. We are in UV space here. Actually, just wanted to put one more word. Also call that texture wrapping sometimes. You'll see that as well. I prefer to say tiling, but wrapping is the same thing. And there's another thing we can do with higher than 1, lower than 0 texture coordinate, which is called clamping. These are just modes that you put to the hardware, and then it basically does what you want it to. The idea is that instead of, when you go beyond 1 or beyond 0 on the negative side, instead of sort of wrapping around the text just to repeat the texture, what you do is you just repeat the last line of pixels on the texture infinitely. And this is particularly convenient if the edges of the texture are completely transparent, so I usually use it with a decal. This word decal, like klistermærke in Danish, is also something you use. So you have a texture, decal texture, where these edges that get repeated, they are actually completely invisible, so you don't see anything. That way you can get just one instance of it, like a small decal on a big polygon. I'll show you. Oh, I had an example for that. Was that this one? It's like a stamp. Kind of like this. It's good to put on things. So imagine we have a the texture itself would look something like this. I'll just put edges on it so you can see. And this is the texture image. What?
I want playing something by speakers.
Ah, the speakers. I think it's some water dripping. Sounds like some fluid or something. But yeah, I think speakers, yeah.
Sounds like this, you know, the
yeah.
electrical circuit error.
Yeah.
Started.
Okay, so we could imagine we have like a big polygon, a big quad, and we want this. Where did that go? Oops. So, using texture clamping, we could do something like this. Like if we had the tiling from before, there would be like multiple copies of this repeated here and here and here and here and here and here. But if we then switch the hardware to clamp instead, and that means that once it gets to the last line of the texture, it just repeats that line infinitely, like in this distance, in this direction, in this, and this. Since it's completely invisible, it lets us place this on using the UV coordinates at the vertices. We can place the decal somewhere on the polygon, and that's why we call it a decal klistermærke. And I'll sketch what is happening in UV space. That's a bit off. Try again. Yeah. So maybe 1, 2, -1. And as we always do, have a UV coordinate system. We draw the text image in UV space. It can always be drawn there. We'll put that. Actually, I shouldn't use this color. And then if we draw the polygon, it's like here. So these are the UV coordinates that we would use to place this decal here. So there will be some negative values for this vertex here, and some 2 something for this, and so on. Okay.